Dear students, in the earlier sessions of this particular chapter, relations and functions, where you have learnt about the definition of an ordered pair, the Cartesian product, and the definition of a relation, and we have worked out some problems on relation. In this session also, I am going to work out some problem. Look at the first problem. Here, the set A is having the elements 1, 2, 3, 4, 5, 6, and a relation has been defined on the set A by this way, that is, R contains all those ordered pairs A comma B, where A and B belong to A. B is exactly divisible by A. That is, what do you mean by B? It is a second element. So, the second element is exactly divisible by A, or you can say A divides B. When we use the word divides, no, it is divisible, divides means the remainder should be 0. Then only we use the word a number divides the other number. For example, 2 divides 4, 2 divides 6. We don't say 2 divides 5, because you can divide 5 by 2, the remainder would be 1. So, when you divide a number by another number, if the remainder is 0, we use the word divides, or the second number is divisible by the first number. Therefore, now you have to consider those elements which satisfy this relation. Now, first the two things you have to calculate. First one, R is, you have to express R in roster form. What do you mean by roster form? That is, the actual elements of the relation R have to be written. That is the roster form. The second one, find the domain and the range. So, what is the domain? What is the range of that one? You have to find out. Now, let me consider one by one. First, I have to write the relation in the roster form. Here, by looking at the numbers, you can say, or if you find difficult to do directly, you can work out in the, you can do the calculation or the working out in the working column. Look here, there are 6 elements 1, 2, 3, 4, 5, 6. Let us take one by one. This is not absolutely necessary. If you want, you can write. Take the number 1, combine with, because we have got only one set A here. So, all the elements of A should be combined with all the elements of A itself. That is, take the number 1. Can 1 divide 1? Certainly, isn't it? So, you can write 1 is divisible by 1. That is, first element is 1, that is a combination 1 comma 1. If you take second number is 1, first number is also 1. So, second number is divisible by 1. Now, next take the number 2. 2 is divisible by 1, isn't it? Because, or you can write 1 divides 1 or 1 divides 2, like that. So, first one directly you can write the elements. Need not write all of them, because if you take the combination, there will be 36 elements would be there. First I take 1 comma 1, or else you can write all of them in the working column. 1 is divisible by 1. That is, you take 1, combine with all the elements. 1 divides 1, 1 divides 2, 1 divides 3, 1 divides 4, 1 divides 5, 1 divides 6. Or here 1 comma 2. See, B is divisible by A means second number should be divisible by the first number. Therefore, 1 comma 3, 1 comma 4 and 1 comma 5 and then 1 comma 6. So, we have combined all the elements of A with the first element of A itself. So, because 1 divides all the number, or all the second numbers, look at 1, 2, 3, 4, 5, 6, all of them are divisible by 1. Now, take the second element 2. Now, here you just take, see the number, this is okay. Now, take the number 2. Now, can 2 divide 2? 2 is divisible by 2, isn't it? 2 is divisible by 2. That means that I can write here 2 comma 2. See, like this only. See, it can be expected for 2 or 3 mark question. So, you have to solve the problem within 3 or 4 minutes. So, don't do all the calculation. Looking at the number carefully, you can do. Combine with 2 with 2. 2 divides 2, or the second number 2 is divisible by 2. 2, 3 you cannot take, because 3 cannot be divided by 2. then take the number 4. Certainly you know that 4 is divisible by 2. You can write that. 5, 2, 5 combination you cannot take, 2, 6 you can take, isn't it? Like this you have to go. So 2 divides 2, 2 is divisible by 2, 4 is divisible by 2, 6 is divisible by 2. So that number 2 is over. Now come to this number. So always any number is divisible by itself. So first we take that combination 3 comma 3, correct? Next 3 comma 4 not possible because 4 is not divisible by 3. 5 is not divisible by 3. Therefore 6 is divisible. Therefore you can take the combination 3, 6. Okay, come to the number 4. Always go in a systematic way, you will not be missing any element. Take the number 4. Certainly 4 is divisible by 4. So any number will be divisible by itself. Next 4, 5 not possible, 4, 6 not possible. Similarly for 5 comma 5 and 6 comma 6. So these are the elements which we can write under the roster form. That is, these are the actual elements. The second number should be divisible by the first number, or if you say in other way, first number should divide the second number. Both mean the same thing, the way we say is different. So 1 divides 1, 1 divides 2, 1 divides 3, 1 divides 4, 1 divides 5, 1 divides 6. So the question can also be asked like this. B is divisible by A can also be given as A divides B. Okay, next 2 divides 2, 2 divides 4, 2 divides 6. Okay, next 3 divides 3, 3 divides 6. Next 4 divides 4, 5 divides 5, 6 divides 6. Now we have answered the first question. Write the number, write the R, the relation R in the roster form. That is, write the actual elements of the relation. Now what's the next question? Find the domain and the range of R. How you have defined the domain here? Domain of R. In the previous sessions I have given you the definition of the domain and the range of R. What's the definition of a domain? Domain means it is the set of the first elements of R and the range is the set of the second elements of R. Now look at the first elements here. What are the first elements here? 1 and then 2 and then 3, then 4, then 5, then 6. Therefore, here you can write the domain is each containing the elements 1, 2, 3, 4, 5, 6. What are these elements? It is nothing but the given set. So in this case, the whole of the given set itself is the domain. Next is the range here. Range means you know that it contains the second elements of the relation, second elements of the ordered pairs of the relation. What are the second elements? 1, 2, 3, 4, 5, 6 and those numbers are repeated here. Again it is equal to 1, 2, 3, 4, 5, 6. What is this one? It is nothing but the given set A. That means in this particular problem we are having the domain as the given set, the range is also the given set and the actual elements of the R in the roster form we have written. So it was given in the set builder form or in the rule method we have expressed the numbers or the elements of the relation in the roster form. So you have to understand the relation carefully. Okay, that is what rule has been specified. When you understand that one, it's easy to write the elements of the set. Now let me move on to the next problem. See, method would be same, but the rule that is applicable to a particular problem would be different. Now let me consider the next problem. Determine the range and the domain, determine the range and the domain of the relation R given by R contains all ordered pairs x comma x plus 5 such that x belongs to the set 0, 1, 2, 3, 4, 5. Here two things have been asked. You have to find the domain as well as the range of that one. See, they have not asked you to find out or write the elements of R in the roster form. See, whether they have asked it or not, you better write the elements in the roster form. That will help you to write the domain and the range clearly without committing any mistake. Now, here the set has not been specified, but in the relation itself it has been given. So, usually we write x comma y or a comma b like that. A is the first element, b is the second element, b is the image of a. Here what they have done is, in that case, now if x and y are given, usually we write y is equal to x plus y. In one of the earlier sessions I worked out a problem, y is equal to x plus 1. Instead of giving y, they have given the relation directly, that is how the second element is related to first element. When this is x, the second element would be x plus 5. So, that is the relation. Second element is obtained by adding 5 to the first element, and that is the relation that has been given here. And next, what are the values of A? Instead of giving set A or B, something like that, the values of x have been given directly. X belongs to the set, means x takes the value 0, 1, 2, 3, 4, 5. So, these are the 6 values which have to be assigned to x here. When x takes a value 0 here, this is 0 plus 5, that becomes 5. So, 0, 5 is one element. When x takes a value 1, 1 plus 5, that is 6. And when x takes a value 2, 2 plus 5, 7. Like that you have to write the elements in the roster form. Though it has not been directly asked, better write the elements in the roster form. Then that will help you to write all the elements of the domain as well as the range here. Now, first I am writing the elements in the roster form. Give the value x, that is what, if you find difficult, in the working column you can write x is equal to 0 means x plus 5 would be equal to 5. X is, or you can write 0 here, x is 1 means 1 plus 5, that is 6. Like that you can write x is 2, the second element is 7. X is 3, it is 2 plus 5, and here 3 plus 5, it is 8. X is 4 means 4 plus 5, that is 9. X is equal to 5 means 5 plus 5, that is equal to 10. So, here 5, 6 and 1, 2, 3, 4, 5. So, 1, 2, 3, 4, 5, 6. 6 values have been given. Now, let me write the elements. X and x plus y. So, it is 0, 5, 1, 6, 2, 7, 3, 8, and 4, 9, and then 5, 10. Now, we have written the elements in the roster form. So, what we have been asked to write here, determine the range and the domain. First, we will write the domain. How do you write the domain here? As you know, it is the set of the first elements. Set of the first elements of R. Set of the first elements of R. That means that, look at this one. What are the first elements of the relation? 0, 1, 2, 3, 4, 5. Write this one. It is 0, 1, 2, 3, 4, 5. See, in the earlier problems, no, the set was given as A, B like that. So, we wrote that one. Here, they have not specified. You write the actual elements. So, this is the domain of the relation R. That is, domain means it is the set of the first elements of R. Now, I want to write the range of the relation R. How do you define the range here? Range means it is the set of the second elements of the ordered pairs of R. That is, range is equal to set of the second elements. Set of the second elements of R. Okay. Now, look at the second elements here. What are the second elements? 5, 6, 7, 8, 9, 10. Write that one. 5, 6, 7, 8, 9, 10. Now, this is how you have to present the answer. So, first see, even if you omit this one, you can directly write the answer, no problem. But better you write that one so that even you will not have any doubt regarding this one. So, read the relation properly, understand the relation, and then first write the elements in the roster form. Whether it is asked in the problem or not, no, better write in the roster form. That always helps you to solve the problem easily or to write whatever have been asked in the problem. Now, let me move on to another problem where the relation is defined in a different way. The definition of range and domain or whatever it is now, the definition remains the same. Here, depending upon the relation that has been specified in a particular problem, we will be having different values for the domain and the range. Now, write the relation or like this, containing the ordered pairs x comma x cube such that x is a prime number, less than 10. X is a prime number less than 10. Write the relation in the roster form. Only one thing has been asked here. You have to write the elements of the relation in the roster form. Now, the relation is like this. If it is given as y, x comma y, they would have given here y is equal to x cube. Just like the previous problem where it was given x comma x plus 5. That means the second element was obtained by adding 5 to the first element. In this one, the second element is obtained by cubing the first element. So, both ways it can be asked. Like here, the relation has been given directly, or if it is given x and y here, then the relation will be specified. But what are the values? In the previous one, the values of x was given. Now, were given to us. Now, a condition is given. What should be given for x? What value should be assigned to x is a prime number less than 10. I hope remember the definition of a prime number. A prime number, a number greater than 1 which is divisible by only 1 and itself. Now, 1 cannot be taken, start with 2. Okay, and the condition is less than 10. If you simply say prime number, it is an infinite set. So, we are giving restriction here. It is less than 10 means start with 2 here. So, you can write here prime numbers less than 10, strictly less than 10 here, less than 10, or first one is 2, this is the only one even prime number, all the remaining prime numbers are odd numbers. Then the second number is 3 and 4 is not a prime number, it is a composite number. Then 2, 3, 5 and 7, then 8, 9, 10. 9 less than 10 means 8 and 9, no, they are not prime numbers. So, we have got only 4 numbers here, 2, 3, 5, 7. These are the prime numbers whose values are less than 10. That means that x should be given the values either x equal to 2, 3, 5 and 7. Now, when x takes the value, you have to calculate cube there. Therefore, let me write like this. First number, it is 2 and then it would be 2 cube. That is a relation. Next one, 3 comma 3 cube. Then third one, 5 comma 5 cube. Next one, 7 comma 7 cube. Even if you write this much, the answer is correct. But here 2 cube, 3 cube, 5 cube and 7 cube, you can get the value here. Actual value can be obtained. Then you can write that one. 2 cube means 8. So, you can write here 2 comma 8. 3 cube is 27. So, it is 3 comma 27. 5 cube is 125. So, you can write 5 comma 125. and the last number 7 cube means it is 343. 7 comma 343. Look here, even if you write only this much, you will be getting the mark for that one. But since the numbers are not very huge here, certainly you can calculate 2 comma 8, 3 comma 27, 5 comma 125 and 7 comma 343. Now these are the elements of the the relation in the roster form. So in this problem I had asked you only to express the relation in the roster form. Suppose they had asked you to find the domain and the range. What would be the domain? Domain would be 2, 3, 5, 7. What would be the range here? Range means the second numbers 8 and 27, 125 and also 343. So read what question properly just to see what is the question and how it has to be answered. So the understanding the relation or the definition of the relation is very important here. Okay, and then you can get the problem solved easily. Now next problem. Here understand carefully and then let me solve the problem. Let R be the relation let R be the relation on Z defined by like this. R contains all those ordered pairs A comma B where A, B belong to Z and A minus B is an integer. Find the domain and the range of R. Find the domain and the range of R. This is the question. So, see, look here, the difference between this problem and the earlier problems what I did in today's session as well as in the earlier session, the sets that were given to you, they were all finite sets. What do you mean by that one? They had finite number of elements here. So you could write all the elements in the roster form, because in the roster form also there would be only finite number of elements. The values of the first element may be 0 to 1, 1 to 5, 2 to some set was given which was a finite set. Even see in the previous problem I had mentioned it's a prime number less than 10. So we could get only 4 numbers between 1 and 10 which were prime numbers, like that. Whether the set was given directly or some condition was specified, we considered most of the problems we considered the finite set. Whereas here Z is an infinite set. What do you mean by Z here? Z means it is the set of the integers. When I use the word integer, it contains the positive integer, negative integer as well as 0. Okay, it is an infinite set. And no specific value has been given for A here. What is the condition given? R contains all the ordered pairs A comma B such that A, B belong to Z, naturally, because we are defining the relation on the set of the integers only. And this is the relation. A minus B is an integer. A minus B is an integer. I am just saying it is an integer. I am not saying whether it is negative or positive. It should be an integer. It should be a whole number. Now, here you cannot give the values for A and B because Z is an infinite set. How many values I can give? If I give, say, A can take the value negative numbers and B can take negative values. Similarly, both A and B can take positive values. No question of taking all the possible combinations here because the set Z itself is an infinite set. So, we consider only the relation here A minus B is an integer. Now, I will just take some 1 or 2 examples, then we will know whether it is an integer or not. Now, let me give some values for you just to make you understand this one. Suppose I take the value A is equal to 2, B is equal to 1. Then A minus B, the difference. What is A minus B? A minus B is 2 minus 1, 1. You know that 1 is an integer. So, 1 belongs to Z. So, this combination I can take. Suppose I take A is equal to 1 and B is equal to 2. I am taking the reverse order. Then, what would be A minus B? 1 minus 2, this is minus 1, this also belongs to Z. Correct? Now, suppose I take A to be 3, B to be 3. Then it is A minus B is 3 minus 3 0, that also belongs to Z. So, whatever combination, whatever set of values you give for A and B. Suppose you take A to be equal to 100 and B to be equal to 200. A minus B would be 100 minus 200 would be minus 100, that is still an integer. Since A and B are taking the integral values here, their difference A minus B, it may be either a positive integer or negative integer, or when they are equal it may become 0 also. So, in whatever way you take the combination of A and B, whatever values you assign for A and B, negative values, positive values, or positive values, negative values, all of them, as you know, we are giving only integral values. So, when you take the difference, automatically it becomes an integer. That means that the domain, of course, domain is the set of integers only, and what is that we have to calculate? Let R be the relation on this one. Find the domain and the range of that one. So, what are all the what can be the first element here? Domain means it is a set of the first elements, isn't it? So, any value can be given for A, that is a set of the first element. A can take negative value, A can take positive value, A can take 0 also. Suppose A is 0, B is 2, let us assume. Then A minus B is 0 minus 2, it is minus 2, certainly it belongs to Z here. Or suppose B is 0, A is 2, then it is 2 minus 0, 2 also belongs to Z, isn't it? That means that A can take all the integral values, that means the set of the first element would be the set of the integers itself. Similarly, to get the second element would be again the set of the integers. That means depending upon what values we are assigning for A and B, we will be getting all the values for the second element, all the values for the first element. That means that the first element A would be the set of integers itself. The second element B, which we call it as a range here, that will also be the set of the integers. So, how do you write this one? See, the domain of R is the set of the first elements, that is nothing but the original set Z, that is set of the integers. Similarly, the range of R is the set of the second elements. Again, the second element would be any one of the integers. Therefore, that also becomes the set of the integers. So, for all the values of A and B belonging to Z. So, how do you write the answer here? You need not give this explanation. I just gave only sorry, to make you understand. So, you have to write here, for all the values of A and B belonging to Z here, A minus B is always an integer. That is, A minus B belongs to Z. So, how do you write this one? It is, the domain is the set of the first elements, that is Z. You write, for all values of A and B means the first element can take any integral value, the second element will be an integral value only. Therefore, the domain of R is the set of the first elements, that is Z, and then the range of R is also the set of the second element, that is nothing but the set of the integers. So, how do you write this one? The domain is also the set of integers, the range is also the set of integers, because the relation is defined in this particular way. Suppose it is defined in another way. A minus b is an integer I have given. Suppose I had given you a minus b is a positive integer. A minus b is a positive integer, then the domain of R cannot be the whole set of integers. It would be only a positive number. We have to consider then a should be always greater than b. Some condition would be there. Here it is given a minus b is an integer. Not a particular value is given here. So, a minus b in the integer means it can be a positive integer, negative integer or 0. Therefore, a and b, a can take all the integral values. Therefore, the first element, that is nothing but domain, is the set of the integers. And depending upon the values of a and b here, the range can be any one of the integer. Therefore, the range of R is also equal to the set of integers, which we denote it as Z here. Now, this is what we have to argue and write here. Okay, no need to do any calculation, because we have been given an infinite set. Infinite set, you cannot consider all the elements here. Therefore, this is the procedure we adopt here. Now, in the coming session also, I am going to work out some problems which are connected with the relation and function. With the relation only, specifically relations here, because we have not yet learnt about the function. So, here when you understand the definition of relation as well as domain and the range, you can work out any problem on relation. Thank you.